Okay. Good morning.
Good morning,
Good
Mr.
morning.
Good morning.
Good morning, Mr.
Okay, I am fine. Okay, good. In our previous time, because of our clash with the regular class, that means the revision class, we lost one class, I think. Now, for whatever, we are going to continue from the previous lesson. We will continue our today, okay? Our today lesson. What was our previous lesson, or what we have seen in our previous lesson? Do you remember? Do you remember?
Motion in one dimension.
Motion in one dimension. Under that, what we have seen? Under
Force.
motion in one dimension, what we have seen?
Force in physics.
Yeah, force in physics, the definition of force in physics. You have learned this one in grade 7, and as revision, we have seen what is the definition of force in physics. Therefore, force means
A push or a pull
a
exerted
push
on a
or a
body.
pull exerting on a body. Yeah, as well as we have seen types of force. We do have two types of force, contact force and non-contact force. Contact force are applied when two bodies contact each other, whereas non-contact body apply or exerted when without contact. In our today discussion, we will see uh, under motion in one dimension, we will see uniform motion, and if we do have extra time, we will continue uniformly accelerated motion. Okay, we will see uniformly accelerated motion. Before that, we are going to see uniform motion. Do you remember what you have seen in grade 7 about uniform motion? Uniform motion is what? Uniform motion is a motion of a body, a motion of a body. We have seen, I think you have seen in grade 7 about uniform motion. Uniform motion means generally a motion of a body with constant velocity or speed in a certain direction, okay? Constant velocity or speed in a certain direction, speed in a certain direction. So when we talk about motion, motion is continuous change, okay? Continuous change in position. If there is continuous change in position, we can say there is a motion. Therefore, motion is a continuous change in a position relative to reference frame again. If you remember in your unit 2 of grade 7 physics, motion is a continuous change in position with relative to reference frame. You know what is reference frame means. Reference frame is a fixed point which all distance are measured from. For example, home, stone, river, mountain, tree. You can take such type of things as reference frame. Therefore, motion is a continuous change in position with relative to reference frame. And motion in a straight line is called motion in one dimension or rectilinear motion. Again, you know about rectilinear motion. Yes, rectilinear motion is motion along a straight line. Okay, motion along a straight line is rectilinear motion. Therefore, motion along a straight line is what we call one dimension motion. Okay, you will learn about two-dimension motion, three-dimension motion in your higher education of your physics class. Okay, there are two-dimension motion, three-dimension motion. For example, in case of two-dimension motion, you can take projectile motion. So motion in one dimension is motion along a straight line. Motion along a straight line or rectilinear motion. You know again rectilinear motion. Rectilinear motion in your grade 7 physics. Rectilinear motion is motion along a straight line. So uniform motion is a kind of motion which a body covers equal distance in equal time interval. For example, if a moving body covers in 1 second 3 meters, in 2 seconds, if that motion is a uniform motion, in 2 seconds, it must be cover 6 meters, okay, 6 meters. Therefore, uniform motion is a kind of motion which a body covers equal distance. Have you seen? Equal distance in equal time interval. In equal time interval. In equal time interval. So, uniform motion is a kind of motion which it to have constant speed or constant velocity, speed with a certain direction or constant velocity. Therefore, for uniform motion in a straight line, or uniform motion in a straight line, equal distance covered in equal interval of time, 1. Speed is constant, speed with direction, or velocity is constant. Velocity is constant. Velocity is constant. And the acceleration of a body is 0. Why? Why? Why?
Because the speed is constant.
The speed is constant. That means there is what? There is no what? Huh? There is no what?
Time.
Change of velocity.
Yes, yes. Because there is no one. There is no change
Change of velocity.
in velocity. Excellent. There is no change in velocity. If there is no change in velocity, your acceleration become 0. Why? For acceleration is equal to change in velocity over time taken. If your final velocity and the initial velocity is equal to final velocity minus initial velocity,
The initial velocity.
0. Yeah, 0. Then 0 divided by
If the
time.
initial velocity is in rest, it will be 0.
Not only for the initial velocity is because of at rest, because of they are equal. Have you seen? Constant means velocity is constant means initial velocity and the final velocity are what? Equal. If they are equal, when you subtract, you will get 0 value. 0. Therefore, acceleration is equal to what? 0. Therefore, for uniform motion, equal distance covered in equal interval of time, speed or velocity are constant, acceleration is 0, okay? Acceleration is 0. Do you have any question on these points? I think this one is somewhat it is revision. You have seen this one in grade 7 too. So the other point, the average speed of a moving object is given by average speed is equal to total distance traveled by total time taken. Why we talk about average speed, a moving body can speed up, speed down, or decrease this speed and increase this speed, as well as it can move by constant speed. When we calculate speed, we must calculate what the average speed. The average speed is what? Total distance traveled by total time taken. From this one, for example, average speed is equal to total distance over total time taken. From this one, distance is equal to, or total distance equal to average speed times time, okay? Average speed times time. Don't forget, for example, in your next physics, you will see what average speed means. For example, average speed is equal to initial plus final divided by 2, it can be. And it do have, for example, to calculate projectile motion, it help you. These concepts help you in future, okay? It help you in future. The other point we are going to see under this subtopic is velocity. Velocity is the speed in a given direction. This means, again, you have seen as speed is vector physical quantity. Therefore, velocity is equal to v with arrow. is equal to speed.
Speed over time.
Velocity is equal to speed over time. Are you sure?
Velocity.
Speed with direction. Speed plus direction. Okay. Velocity is speed plus direction. Speed which do have direction gives for you velocity. And velocity is a vector physical quantity. Vector means it's described by both magnitude and the direction. As you have learned about vector in grade 7, described by both magnitude
Direction.
and direction. And speed depend on what? Speed depend on what? Depend on what? Speed depend on
Distance.
distance. Are you? Yeah. What about
Displacement.
velocity?
Displacement.
Displacement.
Acceleration.
Yes.
Displacement.
Depend on displacement. Depend on displacement. Velocity depend on displacement. For example, average velocity is equal to change in displacement over time taken, or total displacement divided by time. This implies average velocity is equal to change. This delta represent change in displacement over time taken. Change in displacement over time taken. Change in displacement means final displacement minus initial displacement over time taken. In case of distance, for example, distance is path followed. It depends on the path followed, but displacement does not depend on the path followed. Therefore, change in displacement means final minus initial. So speed plus direction gives for you what? Velocity. The other points, the SI units of velocity and the speed.
Meter per second.
Velocity
Meter per second.
meter per second, which is equal to meter times second is a power of -1. Second is a power of -1. Therefore, average velocity is equal to change in displacement divided by time. For example, in case of this one, displacement can be given for you in different direction. For example, 20 meter at north direction and then 30 meter at south direction. If such type of displacement is given for you, change in displacement is equal to the difference between them, 30 minus 20, which gives for you 10 meter per second to meter to south, okay, to south. Therefore, you must know this one. The other point, if a body returns to, it is initial points. Displacement becomes 0. Why? As a result, velocity becomes 0, but average speed will not be 0. Have you seen these points? If a moving body, for example, you can take this one, point A. If you take, there is such types of displacement, and this body again come back and return to its initial point, it is displacement become 0. Why?
Because their direction is the opposite.
If you subtract or if you add, for example, assume this one is 10 meter. What about the reverse of this one? Negative 10.
10 meter.
10 meter plus negative 10 gives for you
0.
0. Yeah. Therefore, the displacement becomes 0. But what about the distance? The distance of this body. Is it 0 or different from 0?
20.
Yeah, 20. Distance does not depend on the direction. It depends on the path followed. Yeah. Therefore, as a result, the speed will not be 0. Why? For distance is not 0, okay? Distance is not 0. Because of the speed will not be 0, distance will not 0. Have you seen the difference between them? Have you seen? So if a body returns to its initial position, the displacement is 0. As a result, velocity is 0, but the average speed will not be 0. Okay? You must understand these points. You must understand. Okay, let us see one example. A boy traveled 10 meters to east and returned back to its initial position in
100 meters
second.
to
What are his average speed and the average velocity? Have you seen this question? Try this question. Try this question. A boy traveled 10 meters to east and returned back to its initial position in 50 seconds. What are his average speed and average velocity? Have you seen? What is your total distance from this one? What is your total distance?
10,000.
100.
100 only. 100 only. For example, look. Take this position. 10 meters. 100 meters, sorry. From these points, return back at its initial position, or he returned back to at initial position. What about the distance? Twice of the first distance. Have you seen? Therefore, 100 meter plus 100 meter. How many?
20,000.
No, 200. 100 plus 100, 20,000. 100 plus 100, 200 meter. Have you seen? It is his distance. What about his displacement? Change in displacement.
0.
0. Why? Again?
Because he's going back.
Yeah, going back. That means 100 meter minus 100 meter, 0.
Which is 0.
Yeah. What about his time?
50 seconds.
15 sec. What's required one?
Average speed and average
velocity.
velocity.
Average speed is how many? B. Average velocity is how many? Solution for A, for example, for A, average speed is equal to total
Displacement over
distance
time.
divided by time taken. What is your total distance? Your total distance?
100 meters.
200. Excellent. 200 meter divided by what?
50 seconds.
3 seconds.
50 seconds.
0 cancel by
Which
0.
is 4
4
meter per second.
Meter per second.
What about average velocity?
0.
Average velocity is equal to change
0.
in displacement
Over
divided
time.
by time. That means 0 divided by
0.
50 seconds. Any number divided by 0. 0.
Is 0.
Equals to 0.
Have you seen the difference between them?
Yes.
Yes.
Therefore, you must know What's the difference between velocity and the speed? If one question is given for you, you can calculate its speed as well as it is velocity. It is velocity. Okay. Do you have question on this point? Do you have question?
No,
Okay.
No.
no, mister.
Okay. Let us see question number 2. For example, number 2. An object is moving along a straight line, a straight road at constant speed of 25 km/h. Have you seen? 25 km/h. What is the distance? Total distance covered in 4 hours. This one is very simple. Try it. Try it. Try. Have you seen? What's given for us? Given. What is given?
Distance?
Speed.
Right. Okay, how many?
25 km/h.
Is it distance or speed?
Speed.
This is speed. Speed. Let us take as average the speed. 25 km/h. What about another given? Yes? No, again we do have only time. Time how many?
4 hours.
4 hours.
Required.
Total distance.
Total distance how many? From, for example, average velocity is equal to total distance divided by time. From this one, total distance is equal to average velocity times time. Therefore, 25 km/h times 4 hour. Hour cancelled by hour. Have you seen? Multiply 24 multiply
100
by
kilometers.
100 kilometer.
100
kilometer, or how many meter? 10 to the power of 6.
1 million.
1 million meters. So if 2 of them is given for you, you can calculate the 31. If 2 of them is given for you, you can calculate for the 31. Do you have question? Question. So in our in our today discussion, we have seen what is uniform motion. We will see in our next, maybe by Zoom class or by regular class, we will see how we can represent uniform motion by graph. For example, if you wanted to represent by graph uniformly motion, it is speed or velocity is constant. Okay, the motion of a body which equal distance is covered in equal interval of time is what we call uniform motion. And in uniform motion, speed is constant, acceleration is 0, or velocity is constant and acceleration is 0. Okay, because of there is no change in velocity. In our next period again, we will see uniformly accelerated motion. What do you know about uniformly accelerated motion? What type of motion we can say uniformly accelerated motion? What type of motion?
A motion that is an object that's along a straight line And with a
Motion.
constant increase in its velocity.
In velocity. Increase in constant velocity.
Yeah.
Velocity is not constant. It increased by constant value, okay? By constant value. That means acceleration is what? Acceleration is
The
constant.
time rate of change of velocity.
Time rate of
Therefore-
a change of velocity.
Therefore, in uniformly accelerated motion, acceleration is constant, okay? Acceleration is constant. Acceleration is constant. Therefore, before we are going to see uniformly accelerated motion, what is acceleration means? Acceleration is
The rate to at
the
which velocity
rate of
Time rate of change of velocity.
Velocity.
velocity. That means the rate means, for example, what's rate mean? Rate.
number.
Rate.
Something divided by time.
Something divided by time. Therefore, this implies acceleration is equal to change in velocity divided by time. Something divided by time. In case of this one, velocity divided by time. Therefore, acceleration is equal to final velocity minus initial velocity over time. Over time. Therefore, to calculate acceleration, you must use this one. If a body starts from rest, if a body starts its motion from rest, initial velocity is equal to 0. Initial velocity is equal to 0. As well as if a body comes to rest or stop, if a body comes to rest or stop, it is motion, final velocity is equal to 0. Final velocity is equal to 0. Again, if final velocity is less than initial velocity, this one shows deceleration, or what? Negative acceleration, okay? Negative acceleration. You must know such point, okay? Such point. Deceleration means negative acceleration. For example, if a moving body decreases its velocity, you will get negative acceleration. What do we call deceleration? If a moving body decreases its acceleration, its velocity, we will get deceleration or negative acceleration. The SI unit of acceleration is meter per second square. So uniform motion is as I have. Uniformly accelerated motion is as I have. First, the motion of a motion increase by constant velocity, okay? By constant velocity, and then at the end, its acceleration is constant, okay? Its acceleration is constant. Therefore, we will stop on these points. Next spread, if we do have Zoom class, we will see how we can represent uniformly motion and a uniformly accelerated motion by graph, okay? We will see, and then we will focus on these points. But we can represent by table or by graph, okay?
Okay.
And for our today discussion, enough for us.